A steel warship named USS Oregon was supposed to be America's fast answer in 1898. Spain was threatening U.S. interests in the Caribbean, and Oregon waited on the wrong ocean, anchored in San Francisco, thousands of miles from the fight. There was only one problem with being fast. There was no shortcut. To reach Florida, Oregon couldn't cut through Central America. The Panama Canal didn't exist yet, so the ship was forced to drop south, chase the coastline into colder seas, and claw its way around Cape Horn, nearly 14,700 nautical miles. 66 to 71 days. In a war measured in weeks, that detour wasn't just inconvenient, it was strategic panic. That panic helped justify a canal, a man-made wound through the continent that would turn two oceans into one route. For a century, the world treated that wound like a guarantee. Container ships, fuel tankers, grain carriers. Our entire supply chain learned to breathe through a few narrow passages. And here's the uncomfortable part: those passages are failing at the same time. One is drying out, another is being shot at. Others are straining under traffic politics and climate. When a choke point breaks, ships don't stop moving, they just spill into longer, darker water. More days at sea, more fuel burned, more risk accepted. 100 years after Oregon, we built the shortcuts. Then we bet everything on them. The Panama Canal looks like a strip of water on a map, clean, quiet, inevitable. But it isn't a river. It's a machine. And like any machine, it runs on a fuel you can run out of. That fuel is fresh water. Every ship that climbs through Panama's locks has to be lifted step by step using huge chambers that fill and drain like elevators. The water that does the lifting isn't seawater from the ocean. It's fresh water pulled from the canal's watershed and stored in Gatun Lake. And here's the part most people never picture. Once that water is released, it flows out to sea. It doesn't get pumped back up. It's gone. A single transit can flush roughly 50 million gallons, enough to make the canal feel less like a bridge and more like a leak. Multiply that by thousands of ships a year, and you realize Panama doesn't just connect oceans, it bleeds a lake. So when the rain doesn't come, the math turns lethal. During the recent drought, Gatun's level dropped from the high 80-foot range toward about 80 feet. 8 feet doesn't sound like much until you're trying to float a fully loaded cargo ship over a channel that suddenly has less margin for error. Less depth means less draft. Less draft means less cargo. And for the biggest ships, it can mean you don't go. Authorities began rationing passages. Daily slots tightened. Weight limits kicked in. Ships stacked up on both sides like a traffic jam you can't drive around. Some carriers paid premium prices at auction to jump the line. Others lightened ships, offloading cargo elsewhere, then reloading later just to meet the canal's new limits. And the result wasn't subtle. Total transits dropped by roughly a third in a single year. For shipping, that's not a slowdown. That's a missing artery. As Panama choked the detour, Oregon, once feared, started reappearing on modern schedules, because when a shortcut is powered by rain, drought turns the guarantee into a countdown. Then, while Panama was drying out, another shortcut was failing for the opposite reason. It wasn't running out of water. It was running out of safety. At the southern mouth of the Red Sea sits Bab el-Mandeb, the Gate of Tears. It's a thin pinch point between Africa and the Arabian Peninsula, the doorway into the Suez Canal, and one of the fastest routes between Asia and Europe. On paper, it's the clean line. In real life, it's a corridor where a merchant ship can become a headline. When attacks escalated in the region, the risk calculation changed overnight. Missiles, drones, fast boats. The kind of threats that don't need to sink you to ruin you. Because the moment insurers stop believing they can price the danger, the route collapses. Premiums spiked. Some coverage got restricted. In certain cases, insurers refuse to cover transits at all. And once that happens, the decision isn't heroic. It's arithmetic. A shipping line can't send a billion-dollar vessel through a war zone if the loss can't be insured. Not in a business where margins are already thin. So ships turned away. Instead of threading the Red Sea and slipping through Suez carriers, started pushing south around the Cape of Good Hope at the bottom of Africa. The move looks like a line on a map. On the water, it's a punishment, extra days. At sea, extra fuel, more wear, more crew time, and more exposure to storms. The world's fastest highway became a detour road with no lighting, and it didn't take a few companies to do it. It took almost everyone. Once the majority of container vessels reroute, the effect isn't local, it's global. Ports get surprised by arrivals they didn't schedule. Empty containers end up in the wrong hemisphere. Timetables stop being timetables and start being guesses. Panama was choking from drought. The Red Sea was closing from fire, and the world supply chain was now being forced to breathe through longer, riskier oceans at the exact moment it could least afford the extra distance. Oh, here's the part the headlines miss. The world doesn't only ship things, it ships time. A container vessel isn't just carrying sneakers and electronics. It's carrying the promise that those goods arrive on a certain week at a certain port with a certain number of cranes waiting. Modern logistics is basically a giant schedule floating on salt water. And distance is what breaks it. In shipping, there's a simple idea that quietly runs everything: ton miles. You take how much cargo you're moving, multiply it by how far you're moving it, and that number tells you how much work the global fleet has to do. If the distance suddenly increases because canals close or routes become too risky, the world doesn't magically get more ships. The same fleet now has to cover more ocean. That means vessels are busy for longer. A ship that used to complete a round trip in, say, 8 weeks might suddenly need 10 or 12. That doesn't sound like a catastrophe until you realize every extra day is a day that ship can't be used somewhere else. In the aggregate, it's like removing ships from the fleet without actually removing them. And the bill shows up fast. A longer route can add huge fuel costs, sometimes millions of dollars per voyage. It adds crew overtime, maintenance, delays. It drags containers out of circulation so ports run short in places where demand spikes. It turns inventory planning into gambling. Do you pay higher shipping now or risk empty shelves later? This is why detour is a misleading word. A detour suggests a side street. What's happening here is more like stretching a rubber band to the point it starts thinning and snapping. Because when Panama restricts traffic and the Red Sea turns hostile, the ocean doesn't just get bigger, it gets heavier. And every company on the planet feels that weight, whether they're moving iPhones, fertilizer, or fuel. Nuts. When one shortcut fails, shipping can usually absorb it. Routes bend, schedules slip, costs rise, but the system stays upright. The danger is when failures stack. Panama doesn't just save distance, it saves time on the safest water available, relatively sheltered routes that avoid the worst of the open ocean. The Red Sea doesn't just connect Asia to Europe, it keeps ships out of the long swing around Africa. So when Panama restricts passage and the Red Sea becomes a live fire corridor, the map starts losing options in real time. The easy routes don't just get longer, they get riskier. Some detours are expensive, others are dangerous, and a few are both. That's when planners start making choices that feel like something from another century. Not which port is faster, but which ocean is survivable. Not how much will this cost, but what happens if we lose a ship? Because at a certain point, there aren't many lines left to draw. If you can't reliably use Panama and you can't safely use Suez, then the alternatives aren't clever. They're brutal. The biggest ships still have to move. Fuel still has to flow. Food still has to cross oceans. The question is only how far the world is willing to push those ships, how much extra sea it can tolerate before the math collapses. And for some routes, the next option isn't a canal at all. It's a passage sailors have feared for generations, where two oceans collide and the weather doesn't negotiate. If shipping has a nightmare level, this is where it starts. Between the southern tip of South America and Antarctica, the Pacific and the Atlantic slam into each other through a gap barely 500 miles wide. It's called the Drake Passage, and on a calm day, it's still not calm because nothing blocks the wind. There's no continent to slow it down. The air circles the planet gathering speed, and then it hits that funnel and turns the sea into a moving wall. Sailors have measured this place in losses. Hundreds of ships over the centuries swallowed or shattered in water that doesn't forgive mistakes. Winds can scream past 50 miles an hour. Waves can rise like buildings. And every once in a while, the ocean throws a rogue wave, an isolated burst of violence that can slam a vessel injure crew or kill someone before anyone even understands what hit them. In a world of GPS and satellite forecasts, you'd think that fear would fade. But the Drake isn't only about weather. It's about physics. It's about currents and pressure systems and a conveyor belt of water that's always in motion. Even if you see a storm coming, you can't always outrun it. Sometimes the storm is everywhere you're trying to go. Now imagine choosing this not because you want to, but because the shortcuts failed. A detour around Cape Horn is not a simple reroute. It changes what delay means. It stretches a trip into a test of endurance. Containers don't just arrive late. They arrive after they've lived through the kind of seas that break cargo loose, shake engines, and grind crews down for days. And here's the terror hiding inside the spreadsheet. The more ships take longer routes, the more crowded those longer routes become. You don't just add risk, you concentrate it. More vessels in harsher water means more chances for something to go wrong. Mechanical failures, accidents, injuries, rescues that are harder and slower because you're far from everything. This is what it looks like when the world's supply chain stops being a network and becomes an ordeal. And once ships start choosing the Drake, you realize something frightening. We didn't eliminate the old oceans. We just forgot we still owed them. No, up to this point, the story sounds like nature and war drought in Panama, missiles in the Red Sea, and ships pushed into violent water because the planet is unstable. But there's another choke point in this system. It isn't made of rock or geography, it's made of paper. In the United States, a century-old law, known as the Jones Act, controls what ships are allowed to move cargo between American ports. The rule is simple on the surface. If you want to carry goods from one U.S. port to another, the ship has to be built in the U.S. owned by U.S. companies and crewed primarily by Americans. Supporters call it national security, a way to guarantee shipbuilding capacity and trained mariners in a crisis. Critics call it a bottleneck disguised as protection because building ships in the U.S. is dramatically more expensive than building them overseas. In practice, that cost difference doesn't just raise prices, it shrinks the fleet. Fewer qualifying ships, higher operating costs, less flexibility when the system is under stress. And this is where the thriller becomes bureaucratic, because laws don't care that the ocean is on fire. The Jones Act doesn't relax because Panama is dry or because Suez is dangerous. It doesn't bend because a region is short on energy or because a storm season gets worse. It's a fixed constraint inside a moving crisis. So even as global routes stretch and detours multiply, the U.S. has its own internal rule set that can force cargo into slower, more expensive paths or block certain movements altogether. When the world shipping network loses shortcuts, every country gets squeezed. But in the U.S., there's an extra squeeze, one you can't see on a nautical chart. And it sets up a paradox that sounds impossible until you watch it happen. The paradox shows up in the one thing modern countries can't afford: to improvise energy. The U.S. is a major producer of natural gas. It has ports. It has pipelines. It has refineries and terminals built for export. On paper, moving fuel from one American coastline to another should be straightforward. But the Jones Act changes the question from do we have the gas to do we have the ships. For liquefied natural gas, LNG, you can't just load it onto any tanker. It has to be carried in specialized vessels built to handle cryogenic fuel. And here's the brutal detail. There are effectively no Jones Act-compliant LNG carriers in operation. None. Not the kind you'd need to move LNG between U.S. ports at scale. So in certain situations, the United States can end up doing something that looks insane from the outside, importing natural gas into a region that's already inside a gas-producing country because the domestic route is constrained. New England has faced supply tightness and high prices during cold snaps even while gas exists elsewhere in the U.S. California has dealt with its own energy vulnerabilities. The issue isn't that America lacks molecules. It's that the network that moves those molecules has rules, and when those rules collide with a stressed global shipping system, the options get weird fast. It's not just LNG either. The same constraints can shape how fuel chemicals and other critical cargo move between U.S. ports. When international routes are already stretched, when detours are longer, ships are busier, and costs are rising, the last thing you want is an extra restriction that forces cargo to take an even more expensive path. And that's the nightmare logic of choke points. You can be surrounded by resources and still feel scarcity because the bottleneck isn't the supply, it's the passage. Whenever the world feels trapped, someone points north. What about the Arctic? What about the Northwest Passage? The route that cuts across the top of North America, the old explorer's dream that sounds on paper like a clean new shortcut. For a moment, it's tempting. Ice retreats. Summers look open. A line appears on the map that could theoretically shave distance between oceans and bypass the usual choke points. But the Arctic doesn't behave like a normal sea lane. First, the ice doesn't leave, it moves. It drifts, breaks, refreezes, and piles into ridges thick enough to chew steel. Conditions can change faster than schedules. A passage that looks navigable on a satellite image can become a trap in days, sometimes hours. Second, the infrastructure is thin to non-existent. In the major shipping corridors, a ship that loses power can call for help and expect assistance, repairs, fuel, or towing. In the high Arctic, help is a long way away. Search and rescue is harder. Maintenance is harder. Refueling is harder. And if something fails, if an engine problem forces you to stop, you're not just delayed. You're exposed. That turns a simple mechanical breakdown into a survival problem. Cold, darkness, distance, and a ship full of cargo that might be drifting in ice while the world waits for a rescue that takes days to arrive. That's why the Northwest Passage isn't the release valve people want it to be. The traffic numbers are tiny compared to global routes, and they can swing wildly year to year. The Arctic can tease you with a window, then slam it shut. So yes, there is a potential shortcut up there, but it's not a highway. It's a gamble one the shipping industry can't rely on when the rest of the system is already breaking. And even when a choke point doesn't close, it can still choose winners. Because limited capacity forces triage. When Panama began restricting passages, it didn't reduce shipping equally across the board. The canal has reservation systems. It has rules. And when demand exceeds supply, it has something colder than a queue auctions. Slots go to whoever can pay the most to secure them. That changes what gets moved and what gets stranded. High-margin cargo can absorb premium costs. If you're shipping containers filled with electronics-branded retail parts that keep factories running, you can justify paying more to protect the schedule. For those shipments, a pricier canal slot might still be cheaper than missing an entire season of sales. But if you're moving lower-margin goods, certain bulk commodities, some energy cargo, raw materials, the math is different. A big premium can wipe out the profit. So those ships get pushed outward, forced into longer routes, forced to accept delays, or forced to split cargo in complicated ways just to fit the new limits. And that's how a global disruption becomes uneven. One part of the economy buys its way through the bottleneck. Another part has to go around the world. It's easy to treat the detour numbers as abstract. 15,000 miles around South America, a couple extra weeks at sea. But in shipping, those aren't rounding errors. They're new realities that rewrite contracts, reorder supply chains, and reshape prices. When the shortcuts fail, the world doesn't just slow down. It sorts itself by margin. And the ocean decides who can afford the fastest route through fear. 100 years ago, USS Oregon chased a war it might arrive too late to fight because the planet offered no shortcut. So we carved one. We carved Panama. We scaled Suez. We drew straight lines through narrow water and built a global economy that depends on those lines staying open. But choke points are not guarantees. They're bets against drought, against conflict, against physics, against policy. And when 2 or 3 of those bets go bad at the same time, the ocean doesn't negotiate. It simply makes the world larger. That's what this moment is, not a single crisis, but a system discovering its own brittle design. Ships will still move. Cargo will still cross. Just farther, just slower, just in darker water.
Rerouting via the Cape appears to be the most viable option despite the increased transit time.